if it's the both, it's a common tangent. Or is
Right. The line itself is a common tangent because they both have it.
The line is common and the circles are.
Circles are just whatever. Yes.
So, is it if circles are internally tangent, they will always have a common external tangent and the other way around also?
Yes.
Always?
So it's like a flip flop.
It's always, right?
Always. Okay, don't draw this. Let's just pay attention. How many common external tangents can you draw between these two circles?
Two.
Where?
One on the top and the bottom. Down and one down.
No, you can draw.
Oh.
Externally tangent. That's it. Externally tangent. Tangents that touch both circles but do not pass between their centers. Now, how many internal tangents can you draw? Two. Here and here. Okay? Now, y'all, so whoever said 4 at the beginning, you just told me common tangents, but I was being specific. Okay? All right, watch. These circles are going to get closer together. So close, they're touching. How many common external tangents can you draw?
2.
2 again. Here and here. How many common internal tangents?
3.
Only one. Only one. Okay? To have more than one internal tangent, the circles cannot be touching each other. If they're touching each other, they have only one internal tangent in common.
Can you draw an internal tangent?
These red lines are internal tangents.
Do they cross?
No, this one's internal because it passes between the centers of the circle. Okay, but there's 2 of them. All right, here, how many common external tangents? 2. How many common internal tangents?
0.
None. You cannot draw a line between the centers of those 2 circles that only touches it once. Okay? It would have to go somewhere here, and it's going to cross over more than once. How many common external?
2.
Still 2. Internal.
Wait, how's it?
9.
It
None.
touches here and here.
Oh, okay.
It's externally tangent to both. Internal, none. External,
1.
1. Internal,
None.
none. Okay? So it's understanding the terminology. How many common external and internal?
9.
0, 0. None. Oh, what do we call that? Concentric circles. They share a
Point.
center.
Center point.
They have the same center. Okay, now this is how we use all this stuff.
That's right.
Yes.
They wouldn't really be considered because like one was but if you would, I was just making sure.
I did my best.
I was
Okay.
just making sure that you meant.
Okay, the first thing we see here is that OA and OB are radii of a circle, so they must be what?
Quiz.
They must be equal to each other.
What was the question?
I haven't asked it yet. I'm analyzing the picture based on stuff we know.
Oh.
We know that radii are all equal to each other. I also see that PA is tangent to circle O, and PB is tangent to circle O at point A and point B. So what else do I know?
They're congruent. And right angle.
They're right angles.
They're also congruent.
And when I draw the imaginary line from point P to O, I've created 2 right triangles.
Oh.
Where PO is the hypotenuse of both of them.
2 congruent right triangles.
So PO is equal to itself.
It's B and A.
Can't you conclude something else?
B and A congruent.
That's what we're going to try to prove, and this is how we prove it. If PA and PB are tangent to the circle, then we knew that angle B was 90 degrees and that angle A was 90 degrees, which means we knew that those were 2 right triangles. And PO was congruent to itself through what property? The reflexive property. So those 2 triangles are congruent through the hypotenuse leg congruency theorem. Therefore, PA is congruent to PB because
The hypotenuse leg, that stays
But
hypotenuse and the
don't
leg
you
have to
know
be congruent to
Patrick.
Instead of going through all that, couldn't we have just said since
You're
PA
proving that
and
theorem.
PB are both tangent to the circle, they're equal?
Yeah.
Those
That
are
one
the-
too. But what we're trying to do is prove that theorem.
Well, yeah, that's a proven.
We proved the theorem though. Okay?
Oh.
You can't prove the theorem with the theorem. That's like trying to define a word by using the word.
It
The
actually
definition of rainbow is rainbow.
Right. You know, you can't do that. All right? Now, because we just proved that those are two congruent right triangles.
all the angles are congruent. Well, I mean, congruent to the.
I mean, we just proved it. Okay? Name pairs of angles that are congruent to each other. Okay, the most obvious pairs of angles that are congruent to each other are angle A and angle B. Angle, not triangle. Now, why can I simply say angle A and angle B and I don't have to use three letters? There's only one possible angle A and there's only one possible angle B. What's another one, Jacob?
Angle AOP and angle BOP.
Very good. I just said very good. Very good. All right. What's the third pair of congruent angles, Will?
Ooh, I know.
He just named these.
the opposite side.
Name them.
E, no. APO and OPB.
Okay. Very good. Now, name pairs of angles that are complements to each other. Raise your hand. Darian.
PAO and APO.
PAO and APO are complements.
No. Sorry, I mean APO and OPB. Wait,
What?
Nope.
I don't remember.
Cressy.
APO and ALB.
Yes, you are.
The two acute angles in a right triangle are complements to each other. So APO is a complement to AOP. In the bottom triangle, Jacob,
Angle OPB and angle BOP.
right. These two are complements. Now watch this.
A
Could
B.
you also say that
Yes.
this angle here is a complement to this one?
Yes.
Yes, because it has the same measure as the other. And then you could say vice versa. You could crisscross again. Name two angles that are supplementary.
Angle A and angle B.
Angle A and angle B are supplements to each other. There's another pair of angles in there that supplements.
Oh, I know.
Jacob? No, wait. Patrick. He hadn't answered yet.
AOB and APB.
Very good. Angle AOB and angle APB are supplements.
What? How you know that?
Because what's the sum of these two right here?
Oh, that's gay.
90. And this is 90. So when I combine all those measures together, that's 180.
That's tight, yeah.
So we're just figuring out all kinds of stuff that we know. Okay, before you even read the question, if TO is tangent to the circle at O, what do you know O is?
Oh, it's a 90. It's a
You know it's a 90-degree angle.
45.
Now, if OR has a measure of 6 and OT has a measure of 8, find the measure of RT.
Pythagorean.
You can use the Pythagorean theorem, and it's going
100,
to be 10.
and then it's like 10 and then like that.
Okay, once again, we know that this is a right angle. It says if the measure of OTR is 45, that means this is 45. And OT has a measure of 4. Now, it hasn't asked this, but what's the radius of the circle?
It's
4. But what's RT?